Welcome to a lesson with Dr. Powell. Let's take a look at computing the volume of the top of a sphere. So let's suppose we have a sphere, looks like this, and let's just use it. Perhaps we know what this is already. It's going to be 1/2 the volume of a sphere, especially if we suppose it has radius 1. We know that 4/3 pi r cubed, so 4/3 pi will be the volume of the whole sphere. Divide this by 2. The result should just simply be 2/3 pi. So let's see if that's what we get using a triple integral. So first, we got to set this up. Okay. And volume, we're just going to put a 1 right there. And let's think. Maybe perhaps let's do this. Let's take our z. Our z goes from 0 to 1. That'll be the outer. Now, does it matter which one we choose? No, just as long as whatever we pick, when we pick a z value, we kind of like the cross sections we get. Here, I kind of like these cross sections because they look like circles. Okay, so at a particular z value, we got a circle. Now let's try to figure out the intersect, kind of what we're looking at. So at this particular point, we're going to have what's the x and y value right here. Maybe it might be nice to kind of be thinking of some boundary shapes. For instance, right here, if we were thinking of, let's see, if we thought of this as like the x-axis and maybe the y-axis going this way, then it looks like kind of, if we just look right in the middle there, looks like we have a shape with y-axis here and z-axis here. It's just a semicircle, radius 1. Now that tells me the relationship between z and y, because I know that semicircle equation is z squared plus y squared is equal to 1. And then I'm interested to know what the y value would be right here. So what would the y value be right here? Because maybe let's do y next. So that means as I'm going to this point, then at this particular z value, y will be going this way. Okay, we're going across. And so I want to know where it starts. So maybe it starts here and where it goes here. And so it's going to be going from here to here, perhaps. That's the y value is going to be going across that way. So in order to know this coordinate, well, I can solve for y, and I get plus or minus square root of 1 minus z squared. So it looks like heading from negative 1 minus z squared up until positive quantity 1 minus z squared. And that would be my dy. Next, let's go to x. All right, so if I have a particular z value, maybe I pick a particular, and so at this z value, I have this, this cross-sectional area, and then we're going to go through this with respect to y, but then for each y value, you have an x value, and that cross-section at that particular both z and y value gives you a line. So that line is what you can be going from here to here. Now notice this kind of has a relationship between x and y right here that we have to kind of work out. All right, so we know for this particular because we know this is going to be a semicircle going like this, and we know its radius is actually, well, it's just to that y value right there. What is that y value? We know that y value is, it's square root of 1 minus z squared. So that'd be like the radius of that shape. And so we end up getting a radius of that shape, which is 1 minus, okay, so 1 minus z squared. And then we take a square root. That's the radius. And so if we square that, all right, so we think we have the equation of a circle. with an x squared plus y squared. The relationship between x squared and y squared will be on a semicircle with radius square root of this. And so we'll be looking at this equation. Now, this may look familiar. This is really just the equation of the sphere where we are. So it gives us the relationship of x, y, and z. Hey, why didn't we use it to begin with? Okay, well, we have it. So that's the equation of the sphere right there. X squared plus y squared plus z squared is equal to 1. And that'll give us the relationship here for what x will be going from. So x is going to go from this point to this point at this particular z value and y value. So for this particular z and y value here, we solve for x. And we get that x is equal to plus or minus the square root of 1 minus y squared minus z squared. So it looks like we're going from negative quantity 1 minus y squared minus z squared up to positive quantity 1 minus y squared minus z squared. Okay, so, and that would be x. So we've just set up this triple integral. Perhaps there's much easier ways of doing it, but it was practice setting up the triple integral. Now, I will allow the viewer to actually go ahead and try this integral out and verify that you really do get 2/3 pi out of this, but at least we set this up. Thanks for watching.